This video is from section 4-4, the counting rules. We're going to look at the fundamental counting rule. Fundamental counting rule says, in a sequence of events, the total possibilities is equal to the product of the individual possibilities. In mathematics, when you see the word product, that means we're multiplying. So in this case, what we're going to do is we're going to look at each event individually, figure out how many possibilities it has, list those all out. When we're done, multiply that whole string together. That'll tell us how many total possibilities there are. All right, so we'll go to some examples. Example 17. How many outcomes are possible when rolling a 4-sided die and an 8-sided die? So what I did was just put together a simple item here in a spreadsheet. So the first event, 4-sided die, 4 things can happen. Second event, 8-sided die, 8 things can happen. So 4 times 8 is 32. If you think about, if you were doing a tree diagram of this scenario, first level branch would be 4, second level of branches would be 8 more. You'd have 32 total branches. Example 18. How many outcomes are possible when rolling a 12-sided die and a 20-sided die? Same basic question, larger dies. So the first event, 12-sided. Second event, 20-sided. In this case, we would have 240 possibilities. Now, example 19. How many ID cards can be made with 5 digits? All right, so start out, we have 5 boxes in this case. We need to figure out how many possibilities there are for each box. The first thing you have to realize is there are 10 possibilities, not just 9, because 0 is possible here. So we have 10 possibilities for each of these 5 boxes. When we multiply those all together, we get 100,000 total. That should make sense to you. If you think about it, you have 5 digits. You can put the numbers up to 99,999 in there. Add 0 in there, you have 100,000 numbers. Example 20. How many license plates can be made with 3 letters followed by 3 numbers? All right, so there's no restriction here in terms of, what letters have to start for commercial vehicles, anything like that. This is just how many license plates can you make? 3 letters and 3 numbers. So in this case, we have to look at the first group of 3. We have letters. So we have 26 possibilities for each of those 3 spots. Then we get to the last 3. We're looking for digits. We have 10 possibilities. When we multiply those all together, we get 17,576,000. Now, example 21 is very similar to example 20 with a little bit of a curveball. How many license plates could be made with 3 letters followed by 3 numbers, but with no repeated characters? All right, so the first 3 characters are letters. So we have 26 for the first one. The second one, because we can't repeat the first digit, we only have 25. Third one, since we can't match the first letter or the second letter, we only have 24. The digits work the same way. We start out, we have 10, but then we only have 9 left for the second one, and 8 left for the third one because we don't want duplicates. When we do that, we get 11,232,000 possibilities. So we cut off about 6 million possibilities by eliminating the duplicates. All right, then example 22. How many license plates can be made with 3 letters followed by 4 numbers? This is the current Pennsylvania scheme. So we're back to no restrictions on duplication now, but 3 characters, 3 letters, then 4 digits. So we fill in the boxes, and when we multiply that whole string together, we get 175,760,000. And then finally, example 23, how many license plates can be made? 4 letters followed by 3 numbers. So if the legislature decided, hey, we need even more possibilities, we'll use a letter for that 4th item instead of a digit. If they had done that, we'd have had 456,976,000 possibilities.